I'm going to draw a picture for this one. It says we've got a point, P, -1, -4. So if I was drawing my axes, would you agree that -1, -4 would be down there? They say it's a terminal point of an angle in standard position. That means here's my terminal arm. This would be my angle theta in standard position. And that point is on the terminal arm. What the question is asking us to find is all the exact values. Exact values means we're not going to be able to use a calculator, and that we have to leave answers with square roots and not decimals if they're like that. So this is what we're given, and we need to find sine theta, cos theta, tan theta, secant theta, cosecant theta, and cotangent theta without our calculator. Okay? Now, if you're finding trig ratios, don't ever forget that trigonometry involves triangles. And one of the biggest strategies in this course in trigonometry will be, could you draw a triangle? Well, I don't have a triangle here yet, but I could draw triangles in different places. The place where we want to draw a triangle to relate it to the trigonometry that we know will be to take this back to the x-axis, draw this triangle right here. Why is it important that we go back to the... That will make that our reference. We don't want to go to the y-axis because then we won't have our reference angle. You might see, oh, I could also make a triangle with the y-axis, but we'll always make our triangle back to the x-axis because the definition we learned yesterday was about the reference angle, and angles with the same reference angle have the same sine value, cos value, tan value. And I can figure out, right? There's my reference angle. Do I know any lengths on this triangle? Well, I went over 1. Oh, this length is 4. I went, wow. I know what I just said. I went over 1. I was thinking ahead. So I know this length is 1. I went down 4, so I know that is 4. You will get really good at a squared plus b squared equals c squared in your head. What's the length of the hypotenuse? Close. A squared plus b squared equals c squared. 17. And you will get really good at that. No. So if I look at this triangle, can you see in this triangle the opposite over hypotenuse would be 4 over the square root of 17? Because you know your reference angle, you will be able to tell me what sine of theta is. It's also going to be 4 over root 17, but it's going to be negative. Why is it negative? Because 3, sine has to be negative. So your reference angle tells you the ratio. The cast rule tells you whether it'll be positive or negative. I have to go back to our big ideas just for a second, just for something exciting. Okay? Now, you learned the cast rule, right? Cast rule tells you where things are positive. Your big ideas of our, like the big ideas of our triangle, explain it. If cos is your x coordinate and sine is your y coordinate, and tan is sine over cos. Look at, just tell me a point in quadrant 2, just a random point. -2. Does it make sense that any point have a negative coordinate and a positive y coordinate? The y is sine. Quadrant 2, cast rule. Wow, that's a beautiful T. Quadrant 2, cast rule, says only sine is positive. Y coordinate will be positive. X coordinate, cos, will be negative. Tan will be sine over cos. Positive over negative. Positive divided by negative will be negative. So your cast rule actually gets explained by the unit circle as well, which is pretty cool. Okay, sorry. Back to our question. We figured out sine of theta. Now, is it hard to figure out cos of theta? We've got our triangle. Our reference angle is really important because it tells us that the adjacent side is 1. Yes? So, why is it sine? So this is my reference angle. And if I did sine of my reference angle, sine is the opposite side, 4, over the hypotenuse. Right? SOHCAHTOA. With my reference angle, I would get 4 over root 17. And then for actual sine, I have to make sure that it's negative because it's in quadrant 3. Similarly, when we get to cos, here's my triangle. If I wanted cos of this reference angle, I would get adjacent over hypotenuse, 1 over root 17, negative because it's in quadrant 3. So I'm using the triangle to find my ratios, and I'm using my cast rule to determine if they'll be positive or negative. No. Okay, so yes about sine, cos, and tan from a triangle, right? Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Okay? Which triangle do we use has to come from our reference angle. Okay? Because if I draw a reference angle, in this case, my reference angle, I don't even know what value it is, but I could draw the same triangle in quadrant 1 where everything would be positive. Once I have that triangle, your sine, your cos, your tan, the values will come from that triangle. So if I want to figure out tan of theta, I go to my triangle. Tan is opposite over adjacent. The opposite side is 4. The adjacent side is 1. So my tan value will be 4 over 1. It'll stay positive because it's in quadrant 3. Yeah? So drawing the triangle always has to go back to the nearest x-axis because we need to have our reference angle, because reference angles and angles are related. They have the same ratios. So that's a big idea with reference angles and how they're related. Now, when we want to figure out our reciprocal functions, reciprocal is the flip. So if the long way to do it would be to say cosecant theta, this would be the long way. Cosecant theta is 1 over sine theta. I know that sine theta is negative 4 over root 17. And then if I'm dividing by a fraction, I have to go to my fraction rules. How do you divide by a fraction? You multiply by the reciprocal, and I would get negative root 17 over 4. Reciprocals flip. What's the short way to do this? Okay. See if you can see the short way for the second one. Cos of theta is negative 1 over root 17. Tan of theta is 4 over 1. Cotangent of theta will be 4. This is by using the definition up at the top. Right? Definition of cosecant is 1 over sine. I can replace sine with its value, because I was told that, and then I could simplify to get the answer. Or I could just shortcut. All right, question number 8, and then we've got oh, 4 is very, very, like, this question is very, very important, and 4 is also very, very important, and I think I would like to give you more time for question number 4. So I will give you time to work on question 8.